Every shop has the drawer. You know the drawer. Full of saw blades that died young, chipped teeth, stripped teeth, blades that squealed their way through 100 cuts when they should have lasted 1,000.
And every dead blade in that drawer has a receipt attached.
Blades are one of the sneakiest recurring costs in fabrication. And here's the thing, most blade death isn't the blade's fault. Today, why blades really die and how the machine you clamp them into decides how long they live. This is Bending Better with Ercolina.
Bold claim to open. Most blade death isn't the blade's fault. Defend it.
Think about what a sawtooth wants. It wants to enter the material smoothly, take a consistent bite, and exit clean, thousands of times a minute, identically. Anything that varies that bite kills teeth. And what varies the bite? Vibration, flex, inconsistent feed, wrong speed for the material, loose clamping. Every one of those is a machine problem or a setup problem, not a blade problem.
So start with the biggest one, vibration.
Vibration is tooth cancer. Every micro wobble hammers the cutting edge instead of letting it slice. Teeth chip, the cut wanders, the surface gets rough, and the operator responds by pushing harder, which makes everything worse. This is exactly why Pedrizzoli builds saw bases from heavy cast iron. Cast iron has a damping quality welded steel fabrications simply don't have. It soaks up vibration instead of ringing like a bell.
The same cast iron speech from the saw episode and the Italian iron episode. Third time now.
Because it's the spec that keeps paying you back. Same blade, same material, same operator, cast iron-based machine versus lightweight import. And the blade life difference can be multiples, not percentages. Iron is the cheapest blade insurance you'll ever buy, and you buy it once.
Next killer, feed and clamping.
Two sides of one coin. The bite has to be consistent and the material can't move. On clamping, if the tube can shift even slightly mid-cut, teeth catch and strip. Pedrizzoli's cutting head design uses a double clamping cylinder, holding the material on both sides of the cut, and the roller and jaw layout clamps tubes perfectly. On feed, a human pulling a handle is a variable feed by definition. Tired operator, impatient operator, distracted operator. The blade feels all of it.
Which is the argument for semi-automatic?
The quiet argument nobody makes often enough. On a semi-automatic saw like the Super Brown Semi-Auto, the operator loads and clamps, but the saw controls the cut. Its own feed, its own speed. The manufacturer literally lists better blade life as a feature of the semi-automatic version because the machine feeds better than any human. And on the fully automatic machines, it goes further. The MCL 120's blade feed is electric motor driven and manages the cut in stages, entry, intermediate, and exit, because the blade wants different feeds entering the tube wall than crossing the middle of it.
The saw is adjusting feed within a single cut?
Within one cut, yes. Superior cut quality, cycle time, and blade life, all from controlling the bite. That's also how one machine handles high-resistance tube and delicate thin-wall tube with sensitive surfaces. Thin wall is the classic blade killer for manual saws. The tooth grabs the thin wall, snags, and strips. Controlled entry solves it.
Now speeds. Everyone knows steel and aluminum cut differently. But how wrong are people getting it in practice?
Chronically, aluminum wants high blade speeds with carbide. Steel wants slower and stronger. Stainless slower still, with steady feed. It work hardens if you rub instead of cut. Run a blade at the wrong speed, and you can kill it in an afternoon. It's why the Paris series exists, a saw purpose-built for aluminum's speeds instead of a compromise. And it's why the MCL 120 carries a technological database, stored cutting parameters. So the right feed and speed load automatically for every material. The machine remembers, so the operator doesn't have to.
What about the gearbox? You mentioned helical gears once.
The helical gear cutting head, helical gears engage gradually and smoothly instead of slamming tooth to tooth like straight cut gears. Smoother power means less vibration reaching the blade, better perpendicularity, and the manufacturer says it plainly. Long blade life. It's all one theme. Every part of the machine that touches the power path either protects the blade or punishes it.
All right, practical segment. 5 things a shop can do this week to stop killing blades.
1. Check clamping first. If the work can move, nothing else matters. 2. Match speed to material, every time. No close enough. 3. Watch the chips. Nice curled chips mean a proper bite. Dust or blue chips mean wrong speed or feed. 4. Never force a cut. If you're leaning on it, something's wrong upstream. 5. Audit the machine itself. If it vibrates, flexes, or rings, no blade will ever live long in it. Some shops discover their blade budget is really a machine problem wearing a disguise.
Recap. Blades die from vibration, bad feed, loose clamping, and wrong speeds. Machine problems, not blade problems.
Cast iron dampens, double clamping grips, helical gears smooth the power. Build quality is blade life.
Semi-automatic and automatic feed beat any human hand, and staged cutting handles everything from thick wall to delicate, thin wall.
And stored cutting parameters mean the right speed every time, on every material.
If your blade drawer is filling up, call CML USA at 563-391-7700. Tell them what you cut, and they'll tell you what it should be costing.
Stop blaming the blade, fix what it's bolted to.
Machines in stock in Davenport, Iowa. Call CML USA at 563-391-7700 or visit pedrazzoliusa.com.
Bend better, everybody.